Hey guys, so exciting news. This is the last video before winter break. Are you guys so excited? Like, this is it. Okay, so what we're doing here is something called absolute value integrals. Okay, so you might be wondering, like, how the heck would I do something like the integral of the absolute value of f of x dx? Well, you guys remember, like, what does absolute value do, right? Absolute value, okay, makes everything, could probably fill in the blank here. This makes everything positive, okay? So what we're gonna do here, there's kind of like 3 steps that you need to do here. So the first thing you need to do is you need to find out where that function f of x equals 0, okay? And I'm going to do like an easy example when it's linear, and then an example where you actually have to factor to solve, okay? But once you find where that equals 0, okay, that is where you're going to split your function. So you're going to split your function, or your integral, sorry, split your integral at these values. Okay, so wherever f of x equals 0, that's where you're going to split your integral, and I'll show you that in a second, okay? And then step 3, you are going to take the absolute value of each integral and add them together. All right? Okay, so let me actually show you how this would work. Okay, so let's look at example 1, and we'll do a really easy one to start with, okay, like as basic as it gets. So let's say I asked you to find the integral from -2 to 2 of the absolute value of x dx, okay? So let's kind of go through the steps here, like what did it tell me to do? So step number 1 is to find out where the function equals 0. Well, this time, you guys, the function is just this x. It's pretty easy, right? So step number 1, I'm going to find out where does x equal 0. Well, it equals 0 is 0, right? Step number 2 is to split the integral at these values. Now, you guys, look. This integral is going from -2 to 2. I'm going to split it at x equals 0. So now I'm going to go from -2 to 0, and then from 0 to 2. Okay, so let's go ahead and rewrite that. So you're going to have -2 to 0 of x dx plus the integral from 0 to 2 of x dx. Now, you guys, at this point, we're going to remove the absolute values, okay, of the actual function, but what we're going to be doing is we're actually going to be taking the absolute values of the actual answers, okay, and I'll show you graphically how this looks in a second as well. All right, so let's go ahead and find these integrals. At this point now, you guys, you should be able to do this. It's a very basic integral. So look, the integral of x is x squared over 2, and I'm evaluating it from -2 to 0, plus, and then the integral of x, again, is x squared over 2. I'm evaluating from 0 to 2. Okay, now plugging this in, 0 over 2, that's just going to give me 0, minus, if I plug in the -2 squared is 4, 4 over 2 is 2. Okay, and then plus, if I plug this in, that's 4 squared over 2, which is 2, minus if I plug in the 0, 0 squared over 2 is just a big fat 0. Okay, now look, the two values here are going to be this -2 and this 2. But remember what I said in the beginning, right? We need to take the absolute value of each of these answers. So I need to take the absolute value of that answer and the absolute value of that answer, hence making them both positive, okay? So this is going to just be 2 plus 2, which is just going to be 4. Now, you might be thinking, like, why does that work? Well, let's look at what this looks like graphically, because that's super important too. So check it out. If you remember from Algebra 2 Trig, okay, the graph of the absolute value of x looks something like this. When x equals 1, y equals 1. When x equals 2, y equals 2. X equals 3, y equals 3, right? And same thing on the other side. If x equals -1, the absolute value of -1 is 1. When x equals -2, the absolute value of -2 is 2, and so on and so forth, right? So your graph looks something like this. Remember, those are your v graphs, right? Now look, what am I trying to find the integral of? It said I wanted the integral from -2 to 2. So here's -2, here's 2. So I just want the area under the curve of both of these guys. Now if you look at it, these are just two triangles. This is 1/2 the base times the height, and this guy is also 1/2 the base times the height. Now these guys cancel, leaving me with just 2 plus 2, which again is 4. So it does work, right? I'm not lying to you, which is a good thing. All right, let's look at another example that's a little bit more complicated. Check out this one. So I have the integral from 0 to 3 of the absolute value of x squared minus 4 dx. Okay, so this one's a little bit more complicated. So again, let's just go through the steps. So step 1 is to take your function, which is now this x squared minus 4, and find out where the heck does this thing equal 0. Okay, well I can do it two ways. I can either factor it or just add 4 and take the square root. Why don't we just do that, right? Add the 4, you get x squared equals 4. Take the square root of both sides, and oh my gosh, you're going to get two answers. What do I do? Well, you guys, look at your interval, okay? So the next thing you're going to do is split this integral at these two values. But look where you're going from. You're just going from 0 to 3. Okay, so really the only number that I really care about here is this positive 2, because negative 2 is not even in that region, right? Okay, who cares about the negative 2? It's not even in my integral. Okay, so I'm going to split this going from 0 to 2 and then 2 to 3. So let's go ahead and rewrite that. So I'm going to have the integral from 0 to 2 of x squared minus 4 dx plus the integral from 2 to 3 of x squared minus 4 dx. And you guys remember, once I find these integrals, I'm going to take the absolute value of each answer and then add them together. So that's like the little special part at the end. Now, you guys know how to do this. Okay, let's go ahead and do this together. Ready? The integral of x squared is just x cubed over 3 minus the integral of 4 is 4x evaluated from 0 to 2. Then plus the integral of x squared is x cubed over 3 minus the integral of 4 is 4x evaluated from 2 to 3. This is actually kind of pretty ugly, but we can do it. So if I plug in the 2, that's going to give me 2 cubed over 3, which is really 8 over 3, minus, and then 4 times 2 is 8. Okay, so it's 8 over 3 minus 8. Minus, and then you guys plugging in the zeros, well, that's kind of cool. That just comes out to be 0, right? Now my other integral, okay, if I plug in the 3 cubed is 27. 27 divided by 3 is 3. Minus, and 3 times 4 gives you a nice little 12. So that's the top minus the bottom. That's going to give me 8 over 3 minus, and 4 times 2 is just a nice little 8. Okay, now you guys look. I can't just go and start adding these guys together, because remember, I have to take the absolute value of each answer. So sadly, I'm going to have to find each answer here, take the absolute value, and then add them together. Okay, so let's go ahead and do that. Ready? So my first integral here, this minus 0 is completely irrelevant, but this is really the absolute value of 8 over 3 minus, I can rewrite this 8 as a 24 over 3. Is that okay? Let's go ahead and finish that up. 8 minus 24 is negative 16 over 3, and the absolute value of negative 16 over 3 is just a 16 over 3. Okay, now let's keep going. On this side, I have 3 minus 12 is negative 9 minus, and then 8 over 3 minus 8. Well, you guys, check it out. We kind of already did that here, didn't we? 8 over 3 minus 8 is this negative 16 over 3 that we found here. So why do it twice? So it's minus negative 16 over 3. Okay, so that's going to give me plus, this is negative 9 really, plus 16 over 3, that negative, not negative. But this 9 I can rewrite as a negative 27 over 3 plus 16 over 3. Okay, and then I feel like I just did something wrong here, but let's see if this comes out, I don't know. Okay, then negative 27 plus 16, you guys, what is that? That's 11 over 3, yes? Okay, you guys, this negative 11 over 3, I'm sorry. And then we take the absolute value. So it's going to give me 16 over 3, and then plus the absolute value is 11 over 3, which should give me 27 over 3. Okay, you guys, I so got a different answer when I did this on my paper. Let's see what the heck Miss Cruzy messed up. That's 27 over 3, which is 9. Oh, I see what I messed up. Okay, I'm an idiot. Look at this right here. When you plug this in, that's 3 cubed is 27. 27 over 3 is 9. Man, you guys, why didn't you tell me I messed up? Oh, that's right. You can't because I'm doing a video. Okay, so let's fix this. 9 minus 12. Gosh, this is so embarrassing. It's negative 3. I'm so sorry. Okay, and then you guys, this right here, you still have that over 3, so let's go ahead and write that as negative 9 over 3. And negative 9 over 3 plus 16 over 3, let's see, that's a negative 7 over 3. And that is the answer that I got when I did this. Okay, so then 16 over 3 plus 7 over 3 is going to give me 23 over 3. Oh my gosh, that's so embarrassing. I'm so sorry. All right, that is what I got as well. All right, so again, just be careful on the math. Okay, now you guys, really quickly, what if they gave you something like this? What if I had the integral from 4 to 7 of the square root of x squared minus 10x plus 25 dx? Okay, now look, you have so many tools, right? Okay, so let's try some of them. Like my first thought would be here, man, I do have a really ugly square root, so I'm just going to try a u sub. That's what I would try. So I would go u equals all that stuff inside the square root. And then my du would be 2x minus 10 dx, and then I'm going to go, oh, that's not going to work, because you guys look, the u would become all of this, but I'm going to have like 2x minus 10 as my leftover. You cannot have an x as your leftover. That's a huge problem. So that means u sub is not going to work on this. So that means you have to get a little bit more creative, okay? So let's check this out. This x squared minus 10x plus 25, that thing actually factors. Okay, that factors to x minus 5 times x minus 5, which is really x minus 5 squared. Now look, even in Algebra 2 trick, okay, remember we said, like, if you had square root of x squared, we always went, hey, a square root and a square factor cancel out, and you just get an x, right? Well, you guys, the true definition of the square root of x squared is that it's the absolute value of x, okay? We never really needed that in Algebra 2 trig, but we sure are going to need it now. Now, you might be thinking, like, why is that true, okay? Well, look, if you had the square root of 3 squared, right, that's just the square root of 9, which equals 3. Now, let's try plugging in a negative number for x. Let's say we had the square root of negative 3 squared, right? This is still the square root of 9, which still equals 3. So notice both of these answers are positive. Well, how do they become positive? It's because the square root of x squared is actually the absolute value of x. So look, this problem then is going to go from 4 to 7. The square and the square root are going to cancel out, but we're going to be left with the absolute value of x minus 5 dx. Okay, now you guys, if you want to actually solve this one, I'm going to let you go ahead and do it. The answer is 5 over 2, so do it if you can, okay, just to see if you can do it, because I think you can do that one. All right, remember, set x minus 5 equal to 0, split it at x equals 5, and go from there. Now, one last little thing. Oh my gosh, the last problem that I'm doing on notes. I'm kind of sad here. Okay, check this out, okay, graphically, okay? Let's say they said the following is the graph of a function f of x. And by the way, guys, it's a really easy problem, so don't panic on me here, okay? And let's say that it goes 1, 2, 3, 4, 5, 6, 7, 8, and let's say it does something like this. Okay, and then you guys, it tells you that the area under the curves here, it'll tell you that the area under the curve here equals 9, and then it'll also tell you that the area under the curve here, let's say, is something like 3. Okay, so sometimes they will give you the areas under the curves, which is nice. Okay, so let's look at two possible questions they could give you here. What if they said, find the integral from 0 to 8 of f of x dx? Now, you guys, look, this is totally old news, right? If you want the area under the curve from 0 all the way to that 8, okay, it's going to be the area under the curve, right? So the area under the first curve is 9, plus the area under the second curve is 3. But because it's under the x-axis, you're actually adding a negative 3, so that equals 6. Okay, we learned that literally like a month and a half ago. Okay, but I can do another one now and change this question, make it a little bit more interesting. What if they asked you the absolute value from 0 to, the integral from 0 to 8 of the absolute value of f of x? Okay, so how would you do that? Okay, so you guys remember, we're splitting this where the function equals 0. So you guys, the function equals 0 right here, right? So when we split this, it's really the integral from 0 to 8 of f of x plus the integral, 0 to 4, goodness gracious, I can't do this. Okay, 0 to 4, and then from 4 to 8 of f of x, right? But remember, because it's absolute value, we're going to take the absolute value of both of those answers, okay? So what's the integral from 0 to 4 of f of x? Well, from 0 to 4, it said that the area under the curve was 9. So this is the absolute value of 9. Plus, and from 4 to 8, well, that's from here to here, the area under the curve was 3, but because it's under, it's negative, but we need to take its absolute value. So really, this just becomes 9 plus 3, which is 12. Okay, so when you're doing absolute value, like it really doesn't matter that it's under the x-axis or not, okay? All the areas are going to be treated as positive. All right, so you guys, that is it. My last notes, and then you guys, we're just going to review, and then we'll be done with the semester. I'm so excited.